pseudoscience myself, but
I think it because I've noticed, it depends what you mean by evolution. Because I mean, to me, I believe it. Obviously, we see change, right? If you mean by evolution, say, dogs and wolves share a common ancestor, of course, I believe in evolution. But if you mean dogs and banana plants share a common ancestor, and you believe there's evidence for that, that's where I say, hey, listen, there's no evidence for that, and in my opinion, that would be pseudoscience. So the word evolution is a little bit slippery, if you ask me.
I just want to say hello, Brenda. I guess.
Hello. Hello.
How are you?
Hello, Brenda.
I'm fine.
Good.
Yeah, I mean, well, to me, that's part of it is jumbling up of words, because anyone says, to me, when someone says evolution, what pops into my mind is the idea that humans were at one time, monkeys, and before that, fish. And
is that what the science says?
Well, the science would say that humans and chimpanzees share a common ancestor. So it would have been some type of ape ancestor. But yeah, I would say that there's no empirical evidence for that.
No.
I don't believe there's any evidence for that at all.
Yeah, and they
Really?
say fish before that,
Exactly.
What do you base your conclusion on that there's no evidence for it?
What do I base my conclusion? Well, I look at certain things like, if I want to look at the genome, I see that our genetic information systems are degrading. I see genetic entropy, accumulation of mutations. I mean, this is very, very inconsistent with that type of large-scale bacteria-to-biologist type evolution.
How is that? How does that go against it? I don't understand.
Are you familiar with mutations?
Yeah.
Yeah. So mutations would be typographical errors. Are you familiar with near neutral mutations?
No, I'm not.
So these types of mutations, these near neutral mutations, what that means is they're neither beneficial nor harmful. Therefore, they build up in the genome because natural selection, it's unnoticeable to natural selection. So they're not being selected for or against. So over time, they build up, and that's actually degrading our genome. So it's a downhill process, but evolution is an uphill process. So it's very inconsistent with what we know and what we observe.
Who says evolution is an uphill process?
Well, if you look at the acronym FARM, right? Fish, amphibian, reptile, mammal. Obviously, if we started off as a single-celled organism, moved on to a multi-celled organism, and up from there, obviously that's going to require novel amounts of new information. So in a way that is uphill, I understand it's random, but put it this way, genetic entropy will prevent that from happening.
So who says that evolution is uphill?
Well, the tree of life shows that it's uphill.
Yeah, like for example, single-celled organism
presented upwards. That's not what
Well, Brenda, do you believe? Because I don't want to straw man what you believe. Would you say that?
I'm just trying to figure out what you're saying.
I'm trying to say that this type of large-scale evolution, people can believe it, but the fact is our genome's degrading. Genetic entropy is a fact. We see that, and that's inconsistent with fish-to-fisherman type evolution. So obviously people can believe that, but it's not science. I would call it more of a religion.
How did you decide that it's not science, and how did you decide that genetic mutations are all harmful instead of beneficial?
Well, I believe there's beneficial outcomes. For example, there's a mutation in beetles, winged beetles. They actually lost their wings. So it was a beneficial outcome. But at the end of the day, they lost that information for wings. So there was no gain. There was no gain in information. That isn't the type of evolutionary change that's going to, take your fish to fishermen.
Can mutations gain information?
Well, that's the question, right? Can mutations add new information to the genome? And I would assert no, it can't.
What do you base that opinion on?
Well, what would be your best example of new information being added to the genome? Because obviously wingless beetles, that ain't going to do it. That's a loss of information. So what would be your best example, Brenda?
The ability of certain bacteria to metabolize nylon.
But that nylon digestion, are you talking about the nylon digestion?
Yeah.
Now, what makes you think that that's actually new information?
Because nylon has never existed until humans came around and created it.
But if you actually look at the literature with that, it actually involves the loss of control of the normal with the nylon digestion.
Isn't the ability to digest nylon a new and beneficial trait?
The question is that trait being emphasized from existing information? Because we do know that our information system, it is four-dimensional. It's almost like overlapping code. So if we're decompressing compressed information, now that trait is being emphasized, it's not exactly new information.
So if I change a letter in the DNA, have I added information to the DNA?
I wouldn't say that changing or alter. Like, are you talking about like a point mutation?
Sure.
Point mutation?
Sure, just a simple point mutation. Have I added to the information in the DNA?
Because you're changing the already existing information, whether it's reshuffling of the existing information, you might, let's say a dog population, for example, you're going to get a variety of that dog kind, but you're not going to see anything other than a variation of that dog,
Well,
right?
Let's just say that it doesn't have any real effect, but the question is, does it add to the information in that dog's DNA if I change one of its genes?
If you've changed one of its genes, you haven't added any novel information to the actual genome. You've altered the existing information.
Why haven't I added information to it?
Well, I just think it's pretty obvious that if you're altering the existing information, you're not actually adding any new novel information. How did that bacteria? What's that?
I just don't understand. If I change a piece of the DNA, I've added to it.
Well, you've changed that existing DNA, but a lot of times if it's a point mutation, you've now lost the message, you've lost the word, but you've gained a new word. But at the end of the day, it's a net loss of information.
I've gained a new word. I've gained information.
At the expense of loss of information. So you're not going to get rich by losing money. That's what I'm trying to say.
Well, I don't know what that has to do with it, but I just think that if you change the information in the DNA, you have added to the information. That's what information
but that type
means.
of change isn't going to explain, right, how the four-dimensional genome with overlapping codes that I was speaking of, chock full of information, came about. I mean, changing or altering that existing information, it's not adding anything novel. I mean, do you believe that that's sufficient evidence for large-scale evolution? That type of change will get your bacteria to a whale over billions of years, that type of change?
It got bacteria to be able to digest nylon. And there's bacteria that are digesting there's that big plastic island floating out in the ocean. Well, there's bacteria that have now evolved. It's evolution. Well, and they're eating those plastics.
From what I understand about the nylon digestion by bacteria, it actually involved a loss of substrate specificity. So it actually lost some of its information.
Well, so what? It's still new.
Okay,
it's new. I mean, no bacteria in the history of the world ever encountered nylon until we created it, and then when we did, they evolved to be able to digest it.
Well,
and that's a new trait. It's new.
It's a new trait. Yeah, that's being emphasized by the altering of existing information. Now, because this was a decay of prior information.
Adaptation and evolution, yes. That's how evolution works.
Yeah, but it's going in the wrong direction because it's a horizontal change in the genome. What we're looking for is a vertical change.
What's the wrong direction?
Can I ask, how does speciation, what is speciation in this argument?
Well,
Yeah,
we haven't touched on that, but I'm just trying to get him to understand that altering the sequence of amino acids in the nucleotides is adding information. That's what it is.
yeah, but
And
breaking things down.
every biologist on the surface of the earth will tell you that when you alter the information in the DNA, you are adding to it.
Yeah, but you're not adding anything novel or meaningful, because at the end of the day, you're decaying prior information. So
But
these examples are not going to be satisfactory
but
evidence.
the ability to digest nylon is novel.
See, the thing is, it's a trait being emphasized by the existing information. Now, here's my question about bacteria. If you're familiar with Lenski's experiment, it's been going on for generations because bacteria have short generation times. How come these bacteria have remained bacteria? Bacteria produces bacteria, dogs produce dogs, but you're saying dogs and bacteria share a common ancestor. So why aren't we seeing this type of large-scale evolution in the Lenski experiment?
Are you seriously asking why dogs don't evolve directly out of bacteria?
No. I know that's not how it works. I'm saying bacteria and dogs, according to evolution, share a common ancestor. But we see bacteria produce bacteria, dogs produce dogs. So how is that empirical science?
Bacteria is just a layperson's name. Haven't Lenski's experiments shown speciation within E. coli?
Well, with the actual E. coli,
I do have that right? He has a long-term experiment with E. coli, right?
exactly. Yeah, and he's looking at that bacteria.
And he has observed speciation.
He's observed a variety of bacteria.
Yeah,
There's no large-scale evolution there.
That just is evolution.
See,
That's
the thing
just
is,
what it is.
I agree that
This idea that you have that there's some sort of difference between micro and macro evolution is nonsense. It isn't anywhere in biology.
It is.
It isn't in any biology text you look at. There's
No,
no
it
biology
is.
textbook that will tell you that there is a substantial difference between macro and micro. These are just their convenience for small scale and larger scale, but the theory of evolution. It's just the theory of evolution, and it isn't. And this nonsense that creationists have.
Well, it's not.
It's just micro. Does just micro evolution? It's just wrong.
No,
That's
what evolution proposes, is that there's a difference between evolution and evolutionary theory. They draw a hard line between the two.
Well, there's a difference between gravity and gravitational theory too.
Well, Brenda, here's my question. If you're trying to say that bacteria and dogs share a common ancestor, what's your best evidence for that? Because what you're saying, this variation within bacteria, variation within dog, I agree. Evolution means change in allele frequency and population over time. But
yes, that's what
changes are going in the wrong direction, is my point.
There's no direction. That's the problem.
Of course there's a direction.
No, there isn't. There really isn't. There isn't any direction.
Single cell, multi-cell,
there
fish,
is a big difference.
That's a direction.
There is a big difference drawn between micro and macro evolution. Micro, there's a difference between saying one species becomes another as opposed to interspecies changes.
Yeah. Brenda, let me ask you, do you believe there's limits? So,
no, I don't.
Okay, do you believe that you can get a dog as small as a flea? Because we do know there's insects as small as a flea, like a flea. Or do you believe we can get a dog as big as an elephant? Because we do know there's animals as big as an elephant, like an elephant.
That's just ridiculous. What are you
How's that
talking
ridiculous?
about? How could you have a dog as small as a flea?
Do you believe dogs and fleas share a common ancestor?
All life on Earth arose from common ancestors.
But
so
do you believe dogs
eventually,
and fleas share a common ancestor?
If you go back far enough, we all arose from single-celled organisms.
So do you believe we can get a dog as small as a flea? Because we know there's insects as small as a flea.
No, I don't think you can, because there's physics.
Well, Brenda, do you believe
physics.
dogs and fleas share a common ancestor?
Answer his question, Brenda.
Well, all life is related. All life
but dogs
is related
and fleas.
to each other.
I'm not talking about all life.
Well, I don't know what the common ancestor would be, but it's way back there. Insects and mammals, They will connect on the tree of life somewhere. I don't know where that connection would be, but it
But
would be way back there.
You just admitted that there's limits.
There are physical limits. You can't have a mammal as small as a flea. What are you talking about? Because of physics.
In the genome, so you're saying fleas, elephants, and dogs all share a common ancestor, right?
All life on Earth shares a common heritage. It all arose from common ancestors that can be traced back all the way to single-cell organisms.
Okay,
Very long
Do
time
dogs,
ago.
do dogs and fleas?
I understand it's a cute story, but you're not demonstrating to us how that's possible because the change is going in the wrong direction.
There's no direction.
There's a direction, of course.
No, there isn't. No.
Yes, there is.
Every single biology textbook you pick up will tell you that there is no direction. There is no better.
But where's the empirical?
Humans are not more evolved than bacteria.
Hey, just imagine, just wondering. Tell me about Jesus.
So the thing is, I believe, and this goes to Jesus, this goes to salvation. When we look at genetic entropy, okay, it's the slow accumulation of neutral mutations. On a personal level, that's why we die. On a population level, that's why we go extinct. Now that shows that we need a savior. Genetic entropy,
I'm not sure I get the connection.
And it shows and reveals our need for a savior.
Because I die, I need a savior. I don't understand. I don't understand the connection.
Okay, Brenda, I'm going to explain something to you. Can you hear me?
Yes, I can hear you just fine. I'm having trouble understanding you.
See, the thing is, the effects of these unselectable mutations that I'm telling you about in DNA, it's fatal to molecules to man evolution. Brenda, imagine you work at a car factory, okay? And I know Suave, he likes cars, so I'd like to see his input on this. Now, imagine at this car factory, you drive every car that comes off the production line, okay? Now, if there's anything wrong with the car, such as, say, I don't know, performance problems, some annoying sound, noises, now you take it out to the crusher to be recycled into scrap, okay? Suppose one car has a problem, say, with the engine, so that it is less powerful. This is easily noticeable, we can agree, okay? Now you send that car onto the crusher. Now suppose, here's the problem. Suppose a car comes off the production line with a single rust molecule hidden somewhere in the metal. Okay, we can agree to this. This is not going to have any effect at all on the physical performance of the car. That means it's unnoticeable and the car continues on in its life. But eventually, here's the problem. That rust will spread so that the entire car becomes useless. And this is the same problem we have in biology. This is the problem we have. This is the devolution process known as evolution.
Okay, wait a minute.
I don't have a problem granting that people die.
Well, I do want to ask a question. How does rust spread?
Rust is oxidation of a metal. You just have bare metal, and it interacts with the oxygen in the atmosphere.
I'm comparing them to the near neutral mutations in our genome.
No, I'm asking a question. I've heard this brought up by a lot of people over the years, that once you get rust, it spreads like cancer. And I'm wondering, how does that happen?
It's just exposure to oxygen. If you put your car into an environment with no oxygen, it would never rust.
Right. So a spot of rust doesn't seem to cause...
Exactly. Yep. You're
growing.
Right. Yeah. It doesn't have any effect on the overall fitness of the car, but over time, it spreads.
No,
that car degenerates.
Okay, then how does it spread over time? What causes it to spread?
The oxidization process.
Oxidizing what?
It's just decaying. It's just it's
what is it oxidizing?
The metal, the molecule. Kind of metal? Well, are we just playing word semantics here? I mean, are you denying the fact that cars rust and degenerate over time? I mean, I've worked and dealt with a lot of cars in my time, and give a car 10 years, that thing is full of rust. It won't even pass safety. I mean, if you got
within the metal, what is it that we typically see that we call rust as opposed to what we normally call oxidation? What causes rust?
The only answer I have for you is the oxidization process is what's
Of what
causing
kind of
that.
metal do we see rust in? You don't just have a speck of it in your car. The whole car is typically made of the same material, so it would be called iron. That's right.
Yeah.
And
I'm
so
not
you
sure
can
what
add different elements to your steel, right? But you don't normally just put it in one spot and it doesn't spread. Anyhow, I don't know where you're going with it, but
Yeah,
Well, my whole point-
I don't understand the analogy.
Yeah, I understand the evolutionists don't understand this problem. It's these unselectable mutations that I'm comparing to rust on a car.
who are
It's
you
the
calling?
Trojan
Are
horse
you
for
being
evolution.
smart alecky to me? Or wait, no, I don't understand. My point is you're saying that evolutionists don't understand this? No, I'm saying I don't understand that a piece of steel that is pretty much the same throughout the whole dang body has nothing to do with one little speck. That's all I was getting at.
Well, yeah, no, I'm just saying over time, this rust is mostly invisible. It comes in silently, being so small that eventually it just infiltrates the entire car. And I'm trying to say that these unselectable mutations, these near neutral mutations, it's the same thing because natural selection can't remove them. This is inconsistent
You're
with
comparing an